Hello, I would like to introduce myself to the panelists and judges. My name is Kathinesh Muria from Fairbank S2. In this video, I will be presenting my final year project. The title of my project is Analysis and Development of a Contactless Flow Measuring System using Lora. Why should we carry out this project? What are the issues that prompted me to create this project? Let's see. River is a part of hydrologic cycle. The height of the river surface is a condition that must be considered, especially in the rainy season. If the river is not able to accommodate the water volume, the water will inundate the land, and this condition is called the flood. Floods are the most common sort of natural today, and they occur when a large amount of water overflows the submerges normally dry terrain. The reason I choose LoRa network for my project is LoRa is for long range and it is a wireless technology where a low power sender transmits small data packages to a receiver. When connected to a non-cellular LoRa network, LoRa devices accommodate a vast range of IoT applications transmitting packets. In the graph shows that LoRa uses lower bandwidth compared with other wireless networks. As I told you, we can use LoRa network for all the IoT applications. For example, fan, washing machine and many more. So that LoRa consists low power and able to transmit data to long range. LoRa consists lower bandwidth, low power and low cost to install. By using LoRa, we are able to transmit the data from one place to another place without using router. And also LoRa able to transmit data for long range. To overcome those problems, a measurement system with enhanced velocity detection is required to ensure continuous flow determination for the relevant application. So I have come up with the IoT project. It is a contactless flow measuring system using LoRa. Contactless flow measuring system with a radar measurement method is perfect for the situation where the bottom of the channel as much slate or when sensors can't be mounted on the bottom of the channel or within the medium for various reasons. The collected data can be analyzed to detect abnormalities and prevent flooding in a prone location early. The contactless flow measuring system specifically support the council and flood mitigation initiative to facilitate and efficiently monitor the critical bottlenecks in flood prone. The objective of my project is to design and develop a contactless flow measuring system using LoRa technology and to analyze the performance of radar sensors that detect the velocity and water level. The primary goal of this project is to create an IoT system to analyze and design a contactless flow measuring system using LoRa technology, which allows a long distance communication at a low data rate and power consumption. This project will be completed using IoT for online processing data storage, allowing it to be monitored from anywhere in the world. All these characteristics make the system a viable option for improving long-range communication systems that monitor environmental conditions at low data rates and low power consumption for a variety of applications. This diagram shows the installation of contactless flow measuring system involve hardware and software components. The velocity of water and water level will be detected by the radar sensor and the sensor transmit the data through LoRa network from transmitter to receiver. The LoRa gateway was responsible to get and gather the data from the sensor node and show it to the PC. Once the receiver receives the data, it will send the data to council and flood mitigation. It will initiate them to facilitate and efficiently monitor critical bottlenecks in flood prone. This is the transceiver board attached with eByte LoRa chip. Let's take a look at how the system works. This is the software we use to configure the eByte chip's parameters. Once we have determined the port number, click Open. If the software successfully reads the board, it will display read parameter success. After successfully connecting the board, we should specify whether it is a transmitter or a receiver. This is the result of transmitting data from transmitter to receiver. This is how it works. First, we must set the baud rate, slot bits, and data bits. The board will be ready to transmit data from transmitter to receiver once we save the data, and the data will be sent to flood mitigation and counsel via IoT by the receiver. This analysis may be studied in the future by community engineers or designers who use LoRa application as primary application anticipated for LoRaWAN. The collected data can be analyzed to detect abnormalities and prevent flooding in high-risk areas early. The council can determine the cause of water overflow and suggest solutions. The impact of flooding can be reduced by monitoring the altitude and the velocity river, so it could be an early warning before the flood happened. Thank you so much for watching the video.